if you flip back and look, that was all the information about even and odd functions, right? So we talked about how to look at a graph. If it's symmetric across the y-axis, it's even. If it's symmetric about the origin, it's odd. We also talked about algebraically how to do this, right? F of negative x, negative f of x. So you've got that in your notes. On the back side, we are talking about transformations. Review in that we start off this year, topic 1, with these green half sheets that had this list of all of our different transformations, right? Up, down, left, right, reflection, stretches, compressions, all of that. Okay, we're still using that. It was also in topic 2 that we had that same list. Okay, so the lists are out there. You can always get another one if you need it. But we're going to look at them in relation to cubics and quartics. Okay, so instead of looking at them in relation to our absolute value v's or our quadratics, we're going to use different base functions. So as we look at A, how does the given graph differ from the graph of its parent function? So with the idea on A that your parent function is x to the 4th, okay? And we'll talk here in a moment about what an x to the 4th graph looks like. Not necessary if we're just looking at the equation, but what do those other pieces of the equation do to the x to the 4th graph?
Goes down 18.
Okay. That minus 18, if you recall, a number added or subtracted on at the end is going to move the graph up or down the direction of the sign. I'm going to write it all out here in a moment once we have it. What else do we know?
Yes, look.
It has a
Different word than slope.
vertical stretch or compression.
Vertical stretch or compression?
Vertical stretch.
I'm going to say which one?
By a factor of 3.
When you have a number that multiplies out front, I think it's A on the paper. You have a number that multiplies out front of the function. It's either a vertical stretch or a vertical compression. This is a vertical stretch because 3 is bigger than 1, right? Okay, so that is a vertical stretch. Those pieces sound familiar, don't they? Okay, so I'm going to write this out. Now, the one thing I am going to specify in this lesson, we kind of jump back and forth between a couple of different graphs. Which graph is this being done to in this case? And all this is being done to an x to the 4th graph. So I'm going to write it out along the lines of the function y equals x to the 4th has a vertical stretch by a factor of 3 and translate down 18 units. Okay? So, or maybe just even, I'll say the graph. The graph of y equals x to the 4th has a vertical, make sure you throw the word vertical in there for me, stretch by a factor of 3 and is translated or shifted, give me a good vocab word there. I'm going to say translated down 18 units. Okay? So make sure you get some of the highlights in there. Mention x to the 4th, mention vertical stretch of 3, mention down 18 or translated down 18. Get some good pieces in there. Okay? Should be all review. Those pieces sound familiar, right? Okay. So start looking at B. 5 times x minus 2 quantity cubed plus 4.
Up 4. Right 2.
Okay. What do you guys think? Up 4? Number is added or subtracted at the end, right? Away from the x, it's up or down. Which way 2 did you say?
Right.
Right 2? How's the left or right work? When it's in with the x, right? In the parentheses, in the absolute value, in the square root. It's going to take the graph left or right. Opposite the sign is what I will always say. So right 2. What about the 5?
Vertical stretch.
Okay. It's multiplying out front. It's a number bigger than 1 again. So again, it's going to fall into that vertical stretch category. And what about this little 3 of exponent? This exponent of 3 just tells me this is what?
X.
Yeah, our basic graph is x to the third. And you guys know a little bit about what x to the third looks like, but we'll talk about that more here in a moment. Okay, so put it in words. The graph of y equals x to the third is vertically stretched by a factor of 5 and is translated right to and up 4 units. Again, get the highlights, get the important pieces in there. I feel like I made this too easy on C, but oh well. Too repetitive. What you got?
5 down.
Okay. Minus 5 at the end. It's not in parentheses, so it is going to take the graph down. Yep. Number bigger than 1 out, multiplying out front is going to be a stretch. I definitely made this too repetitive. I don't know what I was thinking. And all of this is going to be done to what graph?
So
X to the third, yes? Okay. Write down some details. The graph of y equals x cubed is vertically stretched by a factor of 2 and translated down 5 units. Okay. Minus the fact we're using x to the third and x to the fourth as our base graph. We've done this multiple times this year, haven't we? Okay. So, again, you can grab another green paper later if you need to, or dig in your folders. You probably have them somewhere, right? Or the top of the blue paper. Okay. As we looked at this, we talked about 2 different graphs up there. The x to the third graph and the x to the fourth graph. On the bottom part, we're going to be working on writing equations for x to the third and x to the fourth graphs. In order to do that, we have to have an idea of what does the base graph look like. So we've talked about the cubic graph before. Cubic graph being y equals x cubed. We've talked about how it's that increasing the curve that kind of jogs through the middle, right? So what I want you to notice here is that the basic y equals x cubed graph will always go through 0, 0. Besides that, it will go through 1, 1. And it will go through negative 1, negative 1. Okay, so those are some key points to notice. The next set of points you would notice on that one would be 2, 8 and negative 2, negative 8, which I don't think our graphs are really going to show that for the most part. Okay, but that's what your basic graph is going to look like before it's shifted, stretched, reflected, anything like that. Your quartic graph. I don't remember, have we looked at quartic graphs in here yet? Not yet? Okay. So your quartic graph, y equals x to the fourth, the basic quartic graph without any other terms. Kind of looks a lot like a parabola, doesn't it? The difference is, though, it's flatter at the bottom, okay? It still has some of the same values because a quartic still goes through 0, 0, 1, 1, and negative 1, 1. However, it would not go through 2, 4 next. The next spot it would go through would be 2, 16. Okay? But this is kind of your basic graph. Got those ideas in mind? Because we're going to look at the bottom and we're going to take that graph that they give us and we're going to write the equation. So we have to be able to identify what's going on. Okay, so A, determine the equation of each graph as it relates to its parent cubic or quartic function. So no question about, well, is it quartic or quadratic when we get there? They're telling us right up front that it is a either cubic or quartic. So as we look at A, before we write an equation, let's identify some pieces here. Like, what kind of graph is A? Cubic. Yes, it has that cubic shape. So I'm just going to write down, I know I'm going to have to use x cubed. What else do you know about this graph? How is it different from the basic x cubed graph?
It's not upside down, but it's reflected across the y-axis.
Okay. No. Well.
Yes, across the board.
Okay.
Okay.
So it does reflect, yes. Okay. That's what Mikhaili was talking about up here, that it's upside down. So when we talk about, we will have to talk about the fact that we need to do a reflection. Do you remember how you do reflections? Reflections, when you look at your paper, involve a negative. It's either a negative out front or a negative on the x. Okay. Technically, we could think of this one either way. Because if my brain also says reflects upside down. But you could also think of it as reflects across the y-axis. It'll work the same in both ways, but it means we're going to have a negative, yes? Okay. What else did you notice? The base graph is centered at 0, 0, isn't it? Where's my graph centered at?
2, 4.
2, 4. So where did my graph move then?
Over to 4.
Okay. It moved right 2. And it moved up 4, yes? Okay. Any stretch or compression?
No.
And why do you say no?
Because it's still like goes over 1 up 1.
Okay, that's exactly what you need to look at there. Look at the relation to the other points to the centering point. The basic cubic goes from the center, goes over 1 either way and up or down 1. And these are over 1 down 1, over 1 up 1. And so it's still going to fit the basic cubic, no stretch or compression there. Okay, so we're going to write an equation. You can write y equals, or I have f of x in my notes, which probably means the homework is going to have f of x. Okay. Reflection says we're going to start off with what out front? We're going to have a negative. Okay. How do I do right 2? Okay. It's going to have to be in parentheses. And the x minus 2 is going to tell me right 2. How do I do up 4? Plus 4, and that is after the parentheses, yes, or outside the parentheses. And where do I put the 3? Yeah. My exponent of 3 is not on the x anymore because there's a left to right movement. So it moves over with the parentheses, and it's right there. Okay, so you just wrote the equation. In other words, if you want to check yourself, go in Desmos, type this equation in Desmos, and see if it gives you the right points. Okay, that would be the way to check yourself. Just if you're like, I don't know if I did this right. Check yourself like that.
Please,
Desmos?
Yeah.
No. Nice try, but no. Always worth a shot. Okay, let's try B. What can you tell me a bit about B? Okay. It's not a cubic, is it? It's definitely an x to the 4th graph. Based on the fact they told us they're either cubic or quartic. So we don't have other options. Otherwise, it kind of looks like a parabola, doesn't it? What else do you know about this quartic?
It is over 1 left on
It moved left 1 and down 3. Okay. And it's not that you have to write these down, but to me it's helpful. Anything else? Not reflected. Stretched or compressed?
Wait, yeah, compressed.
It's the first set of
Or
points.
stretched.
First set of points from the origin is over 1 up 1, isn't it?
Yes.
And that's how the basic is going to look. Okay. Okay. Well, here's my hint. F of x equals. What are you thinking? Okay. X plus 1 is going to represent left 1. The 4th represents, this is raised to the 4th. Again, that left to right is going to push the exponent over. And what else do I need? Minus 3 for down 3. Okay, C.
Quartic.
Okay, quartic. So x to the 4th. Point out the pieces you recognize.
It is over right 1 up 5.
Okay. Right 1, up 5. Did you watch the labeling on the axis? They didn't give us normal labeling, did they? So beware. Okay, beware. That is over 1 because that's how they have it labeled. What else do we know?
Is
Reflection.
Okay, it's upside down, isn't it? Definite reflection. Is there or isn't there a stretch or compression?
yeah.
If it's a normal quartic, what do your first set of points do?
It goes right 1.
Yeah, over 1, up 1, or in this case, it'd be over 1, down 1. So where can we find a point? We can find a point right here and right here, yes? What are those according to the labeling?
Over 2 down 1.
Over 1.
According to the labeling, isn't that just over 1?
Oh, well, yeah.
They're trying to trick you.
Yeah.
That's the best way I can put it, okay? They're trying to be tricky. Notice that going over 2 boxes is the equivalent of going over 1. Going down 1 is the equivalence of going down 1. So is there a compression or a stretch? No, it's over 1, down 1. Okay, let's write it. F of x equals,
Negative.
out front is a negative because it's a reflection. Right 1 is going to be
Minus.
x minus 1 to the 4th. Up 5 is plus 5. Okay. D, what you got for me on D? The graph is an cubic, x to the 3rd. Where's it moving to?
Over left 3 down.
Left 3, down 1. Notice I'm just looking for that centering point to get that information, right? Okay, reflection, stretch, compression, anything like that? Okay, definitely reflection because it goes the wrong way, right? A normal graph would be increasing. This is not increasing, it's decreasing, so it's definitely a reflection. Stretch or compression?
No.
No, looks like it's over 1, down 1, over 1, up 1. So, f of x equals reflection says negative. Left 3 says x plus 3. Cubic says raised to the 3rd. Down 1 says minus 1. Okay. One more. Is this getting repetitive? Too easy? I've just done stuff recently I would think you would appreciate easy. Okay, E is what type of graph? Okay, x to the 4th. Where's it moving? Right 2 and up 6 according to the point, right? Not even going to make me count. That's nice of them. Reflection? No, because it's right side up. Okay. They tell me 2, 6 is a vertex. They tell me the next point is 1, 7. What do you know about 1, 7 in relation to 2, 6? It is over 1, up 1. Okay. Okay, so f of x equals what we have. I'm still looking for a negative. No negative. Right 2 is x minus 2 raised to the 4th plus 6. Okay. Your homework is less than 3.7. You haven't started, you've got a little bit of time to get started. If you've started, you've got a little bit of time to try and finish. Okay. Again, you're going to have to go back and recall even and odd. Information is on the front side of the notes about those. Remember the symmetry options. And then remember the algebraic options. Okay. My suggestion is you get caught up on Savas tonight, because we're going to go into chapter review after this.